A very good morning to all. I am Dr. Anirima and today I will be discussing how to perform the antifungal susceptibility testing of yeast and yeast-like organisms by broth microdilution method. So till now we know how to perform the broth microdilution method for the bacterial isolates. So what I will be discussing is for yeast and yeast-like organism, which is slightly different from the bacterial broth microdilution method. So the three main differences first we have is in the inoculum preparation. Second difference is in the antifungal stock solution preparation and the serial dilution, and third is in the interpretation of result. So first I would start with the step 1, which is inoculum preparation. Is for fungal, we know that for bacterial 0.5 McFarland is equivalent to 1.5 into 10 to the power 8 colony forming unit per ml. But for fungal, it is written here already. We can see that 0.5 McFarland for yeast and yeast-like organism is equal to 1 to 5 into 10 to the power 6 colony forming unit per ml. So after this, what we have to do is we have to perform serial dilution has to be done for this inoculum preparation. So what we are doing is, as mentioned here, first we have to do a 1:50 dilution, followed by which we have to again do a 1:20 dilution of this inoculum. So what is coming 1:50 and 1:20, either we can do it in 2 steps or we can do this part in a single step. So the total dilution then we are doing is 1 in 1000. So this 1 in 1000 dilution, the media we are using is RPMI, Roswell Park Memorial Institute media, using which we are doing the serial dilution of the inoculum. So when we are doing this 1 in 1000 dilution, approximately 1 microliter of inoculum needs to be added, to which 1000 microliter of RPMI needs to be added. So when we are doing this 1 in 1000 dilution, after that we are getting a colony count is getting reduced from 1 into 10 to the power 6 to 5 into 10 to the power 6. The colony count is getting reduced by 1000, and then it is coming to 1 into 10 to the power 3 to 5 into 10 to the power 3 colony forming unit per ml. So this part is the inoculum preparation part. So till here is the step 1. So this is the step 1 for the inoculum preparation. Following this, what we have to do is next we will go for the antifungal solution. So the antifungal we are testing is fluconazole. So the solvent used for fluconazole as per the CLSI guideline is DMSO. So suppose you have to test a range of MIC from 64 microgram per ml to 0.125 microgram per ml. So whenever we are using solvent like DMSO other than water, whenever we are using, the final concentration of the stock solution should be 100 times than the desired concentration which we have to test. So the desired concentration which we have to test is from 64 to 0.125. So the final concentration of the stock solution which we have to prepare is 100 times more than what we desire. So 64 into 100, 6400 to 12.5 microgram per ml. So we have to prepare stock solution of these concentrations. So what we have done is we have prepared multiple stock solutions of different concentrations like 6400, 3200, 1600, 800, 400, 200, 150, 25 and 12.5. So following this, what we have to do is we have to perform a 1:10 fold dilution in RPMI media. So the solvent we have used is DMSO. After preparing the stock solution, what we have to do is first we have to dilute it by 1 in 10 fold. So how we are doing this dilution? We are adding 0.9 ml of RPMI to 0.1 ml of this stock solution. So then it is coming 1 in 10 fold dilution, thereby reducing the final volume to 640, the final concentration to 640, 320, 160, 80, 40 and so on. After this, what we have to do is we have to again do a 1:5 fold dilution again in RPMI. So for this 1:5 fold dilution again, what we have to do is we have to again take 1 ml of RPMI, to which we have to add 0.2 ml of this solution which we have got. So after doing this, the concentration we are getting is, because here we are doing 1:5 fold dilution. So the concentration is coming to 16640 comes to 128, 320 becomes 64, 16 becomes 32 and so on. So this strength is again double the times of strength needed for the broth microdilution, because what I said, final dilution, final concentration what we need is 64. We need the final concentration in the broth microdilution well from 64 to 0.125. So after doing this 1:5 fold dilution, the concentration we are getting is 128, 64, 32, 16, so on. So we can see that this 128 is double the concentration, the final desired concentration. So we needed 64 finally, but this concentration is 128, which is double, and hence we are doing this 1:5-fold dilution. Why we need this as double is, finally when we are adding the inoculum as well as the antifungal to this microtiter plate, there will be a half reduction of both the concentration here as well as the inoculum concentration will again get reduced by half. So next what we will do is, we will take a microtiter plate.
This is the plating scheme which is recommended for broth microdilution as per CLSI.
So a microtiter plate which is having 12 columns and 8 rows. For each row we are having one inoculum. So what we have to do is, whatever inoculum we prepared, this is the step 3. So step 1 was the inoculum preparation. Step 2 we prepared the antifungal solution. And in step 3 what we are doing is, we are adding 100 microliter of this inoculum. So suppose here we are adding 100 microliter of inoculum first, followed by which we are adding 100 microliter of this antifungal stock solution of 120. So when we are adding this 100 microliter and this 100 microliter, what is coming, there is a half reduction of both the inoculum concentration as well as the antifungal concentration. So this antifungal is then coming to 64, followed by which when we are adding 64, it becomes 32, 16, 8, 4, 2 and so on. And the final inoculum concentration again becomes reduced to half. So here we had 1 into 10 to the power 3 to 5 into 10 to the power 3, which is getting reduced to 0.5 into 10 to the power 3. So half of this, and 5 half, 2.5 into 10 to the power 3. So this is the final inoculum concentration as well as the final concentration of the antifungal. Followed which we will further incubate the microtiter plate. On the last column, we will have the inoculum control, which will only have this 100 microliter of inoculum, along with which we will add 100 microliter of RPMI. There won't be any antifungal solution in this inoculum control, and then we will incubate the plate. Overnight incubation of the plate will be done and the interpretation of the result will be done.
So this is an image of a microtiter plate after inoculation and incubation of the plate. So the interpretation of result is done at 24 hours as per CLSI M60. If growth is less, we can prolong the incubation and read at 48 hours. So row 1 to 7 is having different isolates of Candida. Row 8 is having control of antifungal stock solution of each concentration. And we can see that the column 12 is having inoculum control, with which we are comparing the growth in other wells. So the microdilution wells are scored with the aid of a reading mirror. The growth in each well is compared with that of the growth control well. And a numerical score which ranges from 0 to 4 is given to each well using the following scale, where 0 is optically clear, a score of 1 is given when it is slightly hazy, a score of 2 is given when there is a prominent decrease in turbidity, a slight reduction in turbidity is given a score of 3, and a score of 4 is given when there is no reduction of turbidity. The MIC for amphotericin B is defined as the lowest concentration in which a score of 0, that is optically clear, is observed, and for 5-flucytosine and the azoles as the lowest concentration in which a score of 2, that is prominent decrease in turbidity, is observed. So for prominent decrease in turbidity corresponds to approximately 50% inhibition in growth as determined spectrophotometrically. So in this image we can see that a complete reduction in turbidity when compared with inoculum control is seen at amphotericin B drug concentration of 1 microgram per ml in row 1, 2 and 4 at a concentration of 0.5 microgram per ml in row 3, 5 and 7 and at a concentration of 0.25 microgram per ml in row 6. So the minimum inhibitory concentration MIC value is 1 microgram per ml for row 1, 2 and 4. MIC value is 0.5 microgram per ml for row 3, 5 and 7 and it is 0.25 microgram per ml for row 6. However, for certain antifungals like fluconazole, we have to observe 50% reduction in turbidity, which becomes difficult with naked eye, and we can determine by seeing the optical density. This is an image which shows values of optical density of wells read using spectrophotometer immediately after inoculating each well. Then we have to take reading again after 24 hours. So this image shows optical density values read after 24 hours. So as said, the optical density value is determined using a spectrophotometer and we compare the optical density value after incubation with the optical density value of inoculum control, and where it is almost half, that is 50% that of the inoculum control, that is taken as the MIC value for fluconazole. So for example, for the isolate in first row, we can see that half of the inoculum control optical density value, that is 0.5862, is 0.2931, which is the column 6. So the MIC is considered as 2 here.
So I have discussed the broad microdilution method for yeast and yeast-like organism. So now we will quickly recap this broad microdilution method for yeast and yeast-like organism. So what were the three differences? One was in the inoculum preparation, where the inoculum preparation is different for bacterial as well as fungal, where the colony count of 0.5 Macfarlane was also different, as well as for inoculum we had to perform a serial dilution. Followed by this, the second difference was in the antifungal stock solution preparation, where the solvent used was DMSO, followed by which we had to perform serial dilution using the RPMI. Third was in the interpretation of result, which was done by two methods, one manually as per CLSI and another method is the optical density method as recommended by the UCAST. Thank you.